Welcome to EDU World Space.
So in this question, it is given to us that we have a rod, right? We have a rod, and that rod has a radius of 10 millimeter, right? And the problem states that if it is subjected to an axial load of 15 Newton, right? Such that the axial strain in the rod is axial strain in the rod is 2.75 into 10 raised to power negative 6. We are required to determine we are required to determine the modulus of the modulus of elasticity E, right? And the change in the and the change in the rod's diameter, right? And the other thing that is given to us is the 0.023, right? So let's start with the solution. The solution is very simple and it's very easy, right? So now over here we have only one load, right? So that is applied in only one direction. Okay, one load is applied in one direction, right? So what we're going to do over here is that we are going to use the Hooke's law for one direction, right? So that is epsilon sub x is equal to sigma x divided by e, right? And over here, this um, it's sigma sub x. Sorry, right? Let me write it more properly. So this is sigma sub x. So sigma sub x is equal to f sub x divided by a, right? And a is equal to pi r square, right? So now what we're going to do is that we are going to rearrange this equation, right? So we have elasticity is equal to sigma sub x divided by epsilon sub x, right? And we have the expression for sigma sub x, so we are going to substitute it over here, right? This expression, so we have f sub x divided by epsilon sub x by r square, right? So now what we're going to do simply is that we have all those values, right? Given value, just substitute them over here, and we'll have elasticity is equal to 15 divided by pi into 2.75 into 10 raised to power negative 6 into 10 into 10 raised to power negative 3, right? It was in millimeters, so we converted it. So when you calculate it, you will get that it is equal to 17.362 into 10 raised to power 9 pascals, right? And that is approximately equal to 17.4 gigapascals. Now, since the circle will change uniformly, right? The circle will change uniformly, right? And that too in only one direction. In one direction, then we can apply the Hooke's law for either y or z direction, right? Because the um, circle, right, it will only change, and that too uniformly, right? Uniformly change in one direction. So it means that we can apply the Hooke's law. Um, and why we will apply the Hooke's law? Because we also want to know the change in the radius, right? And find the change in radius, right? That is the other part of the question that we are required to solve. So when we'll apply the Hooke's law, we'll get that, and that too, right, on either in z y or z direction. I'm going to apply it in the y direction, right? So epsilon sub y is equal to 1 divided by e, parenthesis start, sigma sub y, parenthesis again start, sigma sub x plus sigma sub z, right? And parenthesis close. This is equal to negative divided by e epsilon sigma sub x, right? Now we have the expression for sigma sub x, so divided by e into f sub x divided by pi r square, right? So again we have all of these values, right? I'll substitute them in over here, and we'll have negative 0.23 into 10 into 15 divided by pi into 10 raised to power 10 into 10 raised to power negative 3 into 17 and 17 point, sorry, it's 17.362 into 10 raised to power 9, right? And this is equal to negative 0.63 into 10 raised to power negative 6, right? And finally, what we are going to do from here is that we will use this information to find out the change in the radius, right? So we have epsilon sub y is equal to del r, change in the radius, divided by radius, right? We are going to rearrange it. So this will become del r is equal to epsilon sub y into r, right? So epsilon sub y is this value, negative 0.63 into 10 raised to power negative 6, and r is 10, right? Um, over here, I'm going to keep it in millimeter, right? So calculate it, you will get negative negative 6.3 into 10 raised to power negative 6 mm, right? And change in diameter is equal to 2 del r, right? So 2 into 6 negative 6.3 into 10 raised to power negative 6, right? So when you calculate it, you will get that it is equal to negative 12.6 into 10 raised to power negative 6 millimeter, right? So this is your complete question solution, right? So this concludes our answer.